You're creating your own reality tunnel. That doesn't mean you're creating reality. Out of reality, whatever that is, out of the infinite flux of energy, you're creating your own reality tunnel, and most people aren't aware of it. Most of
their reasons. And it is not that culture is evolving. The evolution of culture is an epiphenomenon attendant upon the evolution of language. Language is the part of man which is evolving. Culture carries along. At the present moment, we are able to speak 21st century ideas to each other, but our culture is carrying along at about the 1950s level. Nevertheless,
I don't, but there are those that do. So maximally bland computationalism is a framework which can incorporate just about any serious view, I think, that anybody holds anywhere in the world today about how the brain works. Just cast into the mold of computationalism. Because the basic underlying idea is that the brain's job is to get the body that it resides in through life by computing the best thing to do next, given the information that it's taking in from the...
All the matter in the universe, from the galaxies, stars and planets, down to buildings and all living things, including our own bodies, are made of extremely small particles called atoms. If we looked at a piece of copper closer and closer, we would eventually come to copper atoms. These atoms are made of three principal particles. Extremely tiny electrons move in a cloud around the outside. They have a negative charge. Inside is the nucleus. It's made up of protons and neutrons. The neutrons have no charge, and the protons are positively charged. The charge on a proton exactly balances the electron's negative charge. Most of the atom is space, a complete vacuum.
Moving down a staircase instead of moving very smooth and continuous. Now, Einstein stopped because the way things work in the very large is that when energy is released, things move in a very continuous fashion. For example, if we drop an apple from a tree, it moves in a very continuous and predictable fashion, and they expected, in the photoelectric effect, the very same things to happen. They didn't. And so Einstein began to see that the very tiny started to behave very different than the very large. And so there were a series of experiments that began to focus attention on electrons and where electrons would be. And when they began to observe electrons and the nature of electrons and how they behaved, they noticed that wherever they observed or looked for an electron appeared. So the electron went from a wave of probability to all of a sudden collapsing into a very definite particle. And now this whole idea of Cartesian dualism, what Descartes said back in the 17th century, started to get fuzzy again. Because now the subjective person and subjective mind was beginning to have a direct effect on the very objective. And so now the separation between mind and reality and mind and objectives began to merge again. And independent of who was doing the observation, whether they had an academic degree or they didn't have an academic degree, that their actual observation had an effect on the quantum field. And so quantum physics was born as a result of. And now, that means now that all of us, every single person, independent of their creed, or their culture, or their gender, or their age, or their race, that every single person, when they're asked to observe something, has an effect on the very tiny, that we're all participants in the nature of reality. And of course, there were some speed bumps along the way. And it served Descartes very well because he didn't have to deal with issues other than things that were predictable because he was a scientist by nature. He didn't want to deal with influences by the church because If we study history, if we study Galileo Galilei, or we study Giordano Bruno in earlier times, when they said that the earth was no longer the center of the universe, they were persecuted by the church because it went against the very doctrines that ran the church. So Descartes had his own freedom now to study the nature of reality. And things worked really well, and by observation, scientific laws began to develop. And in the 18th century, along came Sir Isaac Newton. And Newton basically said, there are certain definite laws that we can actually put a scientific value on. He knew that force and mass and acceleration are related. And Newton said, if I know the starting point of something, and I know its velocity or its speed, I can determine where it's going to end up. And because of Newton, we're able to put a rocket on the moon. If we know the distance from the Earth to the moon, and the rotation of the Earth and how fast we're going to shoot that rocket, because of Newtonian laws and Newtonian physics, we're able to do some very specific things based on the very large and very objective laws. And things worked really well, and science continued to emerge. And then in the 19th century, Albert Einstein comes up with his theory of relativity and his theory of light. And Einstein basically said, nothing can travel faster than the speed of light. Anything as an object or mass that travels faster than the speed of light will ultimately become energy. And because of his
a point particle that has three-dimensional existence and extension in space. Now, what is fascinating about this is that every time they do one particular experiment, it's called a twin slit experiment, and effectively what they do is they actually fire waves of electromagnetic radiation through two slits in the screen. And the other side of the screen, if nobody's viewing it, you get an interference pattern. It's waves. However, if they place a measuring device or a little device on one or other of the slits, the photons become point particles and choose to go through one slit or the other. It's as if the photons know they're being looked at. Now, this means effectively that if you're not looking at something, or something is not being observed, it's a wave. And not only that, but it's a wave of probability. It's not even a wave like a wave in water. It's a probability wave that an object will be found in one place or another. Mm-hmm. Now, on top of this, it becomes even more complex because there's been a series of experiments done over recent years where they found that not only do photons have this peculiarity, but so do atoms. Not only do atoms have this peculiarity, but also molecules. Very large molecules. There's a guy in Austria called Anton Zeilinger at the University of Vienna, and he's actually he has shown that very large molecules, such as something called a buckyball, that has 60 atoms in its structure, still has this effect of being looked at, and it's a particle, look away, it's a wave. Now, everything you see around you is made up of atoms. Every single thing. So suddenly this brings forward a profoundly deep metaphysical question about the nature of reality. Recently I did the book launch for The Labyrinth, and I was talking to the audience about this, and I do this quite a lot, and I turn around and I say, the one thing that is of intrigue is that you have lived your life so far, and there are people in your life that have died. There are people you have known that have disappeared from your life. The only constant is you as the observer of your world. Now, there is a Danish, I think he's Danish, I'm pretty sure he's Danish, a Danish quantum physicist called Max Tegmark. Max, I think, is based at Princeton. And Max has come up with this amazing application of the Schrodinger's cat thought experiment, the idea that reality is only there if you're observing it. What happens to reality if effectively you're no longer there to observe it? And he concludes that the idea of a universe where you are not there to be observing it is impossible. Therefore, in reality, this is why we continue to live and people around us seemingly die. Because this is our universe, and within our universe, your universe needs you as an observer. Just like my universe needs me as an observer. And what is happening now is that there is an interface of my consciousness interfacing with your consciousness, creating a term that my group use called an egregore. And an egregore is a shared conscious experience. But the minute we move away and look away, that shared conscious experience ceases to exist. It doesn't that at a much deeper level of reality, everything is one. You know, it's coming back, and he called it the implicate order. And he considered that everything within the implicate order are vibrations in what he called the hollow movement. And he argued that reality is holographic. Now, again, before people out there start turning around saying what some other New Age guru, just to point out that Professor David Bohm actually worked with Einstein. David Bohm was actually one of the top particle physicists ever. So, you know, this guy is, again, seriously intellectual guy.
Right.
Now, his model of the nature of reality, working on holograms and holographics. In other words, you're probably aware of this. If you take a holographic image and you smash it into smaller pieces, unlike a normal picture that would actually have the part of the image in the bits, well, what happens is a holographic image has the whole image in each shard of the image. And Bohm again argued that reality was like this, that it was fractal, you know, that everything is contained within itself. Now, what happened was that, quite by chance, he came across the son of Karl Pribram, who was a researcher at the University of Georgetown, came across Bohm's work and told it to Karl Pribram. And Karl was doing the opposite. Karl was going from the inside. He said he came to the conclusion that memories themselves work holographically within the brain. He argued that the brain itself encodes memories holographically. And this is why they've never been able to find within the brain something called the enneagram, the place where memory is located. And the reason they haven't been is because it's encoded everywhere. Okay, a guy called Carl Lashley spent his whole career mutilating rats' brains in order to try and find where memory was, and he could never find it. And he could never find it because he was looking in the wrong place. Right. Now, when Bohm and Pribram got together, there was the holographic model of the brain and the holographic model of the universe. And of course, suddenly there was this huge enlightening point of saying they're both holograms. The brain is a hologram processing a major hologram, and the brain itself is within the universe hologram, and the universe hologram is in the brain.
Motivation, and especially here in Media City, where people make their living out of this kind of things. So how, I'm not sure which of the three, but okay. How detailed and how accurate will the simulations be? And the answer turns out, as we know from experience, computation power is the first issue. You have to have tremendously good computation power to make a really good quality simulation, and good programming, that is good software to explain what's going on, that's the second. But clearly we're making progress. Just look at the games, the original, look at Pong, and look at the kind of video games we have now, right? And so we'll see. What about simulations by other civilizations? Okay, so now we know a lot more about this than we did 30 years ago. We've made tremendous progress. We've discovered more than 2,000 other stars that have planetary systems around them. And we know there is at least on the order of 1 billion or more habitable planets in our galaxy, and there's about 100 billion galaxies for around 10 to the 20th to 10 to the 22, depending what you range, possible sites for life and then advanced civilizations in the universe. So what are the chances that the Earth is the most advanced, the most computationally powerful? Well,
this way, we can understand that our brain is also nothing but a perception formed by the senses of vision and touch. Then, what is the will that sees, hears, and perceives all other senses if it is not the brain? Who is it that sees, hears, touches, and perceives the taste and smell? Who is this being that thinks, reasons, has feelings, and moreover that says, I am me? One of the important thinkers of our age, Karl Pribram, also poses the same question. Since the Greeks, philosophers have been thinking about the ghost in the machine, the small man within the small man, etc. Where is I, the person who uses his brain? Who is it that realizes the act of knowing? As St. Francis of Assisi said, what we search for is the one that sees. In fact, this metaphysical being that uses the brain, that sees and feels, is the soul. What we call the material world is the aggregate of perceptions viewed and felt by this soul. Just as the bodies we possess and the material world we see in our dreams have no physical reality, the universe we occupy and the bodies we possess now also have no physical reality. The real absolute being is the soul. Matter consists merely of perceptions viewed by the soul. Yes, even if we start with the presupposition that matter is real, the laws of physics, chemistry, and biology all lead us to the fact that matter consists of an illusion and to the inevitable actuality of a metaphysical matter. This is the secret beyond matter. This fact is so definite that it alarms some materialist scientists who think matter to be the absolute being. Science writer Lincoln Barnett says in his book, The Universe and Einstein, along with philosophers' reduction of all objective reality to a shadow world of perceptions, scientists have become aware of the alarming limitations of man's senses. All these facts bring us face to face with a very significant question. If the thing we acknowledge to be the material world is merely comprised of perceptions given to our soul, then what is the source of these perceptions? In answering this question, we must consider the fact that matter does not have a self-governing existence by itself, but is a perception. Therefore, this perception must have been caused by another power, which means that it must have been created. Moreover, this creation must be continuous. If there were not a continuous and consistent creation, then what we call matter would disappear and be lost. This may be likened to a television on which a picture is displayed as long as the signal continues to be broadcast. If the broadcast stops, the image on the screen will also disappear.